Let's talk about functions. Now, oftentimes I ask students to define what a function is, and they give me an answer like, oh, well, it's an equation or it's a graph. And I quibble a little bit with those because in my mind, equations and graphs are representations of a function. But to really, really understand what a function is, how could we define it? Well, the best explanation I've ever heard is that a function is like a machine. You've probably heard this before yourself, right? A function is like a machine. It's a machine that connects inputs to outputs. And those are all fancy words, but think of a vending machine, right? My input is $1. I put $1 into the vending machine. My output is a candy bar, right? If we go back to the very early quote unquote computers, one of the earliest machines that was called a computer was this big brass thing, right? And you would program this machine by telling it what you wanted it to do. It's basically a calculator. So you would say, okay, machine, anytime I put a number in, I want you to multiply it by 2. So the function of the machine is to multiply this number by 2. So if I put in a 1, out comes a 2. If I put in a 2, out comes a 4. And if I put in Bob, out comes 2 Bob, right? This machine is just going to multiply anything by 2. Now, let's talk about how we represent this in an equation. The function notation that you may be familiar with is f of x. And I'm going to write a sample function. Why don't I just write this one? F of x equals 2x, right? The one that we just did here. This is describing exactly what this is doing. It's the same thing. The way that I kind of notate each test here, though, is I say f of 1 if I'm plugging in 1. So if I'm plugging in 1 for x, then I would rewrite this as 2 times 1. If I'm plugging in f of 2, then it's 2 times 2. And if I'm plugging in f of Bob, then of course it's 2 times Bob. All right, let's take a look. For the function f defined above, what is the value of f of 4 plus f of negative 2? So we have this function here, this machine, and just to be consistent, let me draw this again, right? This machine says, whatever I have for x, I'm going to multiply it by 2, subtract 17, and divide it by 3. It's a little more complicated of a machine here. Inputs, outputs. And complicating things is that I'm adding f of 4 to f of negative 2, but let's treat these separately. What happens when I put 4 into this machine? Well, I get 2 times 4, that's 8, minus 17, which is 8 minus 17, there we go. Negative 9, took me a second there, divided by 3, out comes negative 3. I put in a 4, I got out a negative 3. So f of 4, I'll just cross that out and say that is negative 3, right? Plus f of negative 2. Well, let's plug a negative 2 in the machine and see what happens. When I plug a negative 2 in, it's 2 times negative 2, that's negative 4, minus 17, negative 21, divided by 3, well, that's negative 7. So I get negative 3 plus negative 7, use the number line again if you need it, right? There's 0, there's negative 3. What happens when I add negative 7 or take away negative 7? Well, I go down to negative 10.